Number 10, again, looks like we've got a linear graph in relationship with the y value being the predicted number of species and the x value being the area of the rainforest. So what do they want here exactly? What equation represents this relationship where P is the area, so P is my vertical, and A is my area, sorry, and P is the predicted number of flowering plants. So I've got a function y that'll be P. Notice all my answer choices are P equals some function of y. Well, my intercept is at 0, 0, so there will be no constant. And no, there's no plus or minus any constant value, numerical values, on the equations for any of the answers. So we only need to determine the slope. We start from 0 to 0. Now, I caution you, don't use a point too close to the 0, 0 line. Pick something further out. That's going to give you a much better answer. So say at 100, it looks like we're a little below 40,000. So what number is kind of below 4 or 40, 400, 375 looks at? That could well be 37,500. In fact, it looks like it is halfway between 35,000, 40,000. So my slope in vertical change is going to be 37,500. My slope's positive. It's upward to the right for a change in x of plus 100. That makes my delta y, delta x for the slope, that is change in y over change in x, 37,500 over 100. Cancel the zeros. My slope equals 375. My x variable is a, so the answer should be P equals 375a. That's the equivalent to y equals mx, where b is 0, to being y equals 375x. The only difference here is my y is p, my x is a, and the correct answer for number 10 is B. Okay. You know, again, this point at 40 and 15,000, that could have worked as well. Number 11. Okay, looks like we've got a function here, one variable that relates p, my y value, to n, the x value, essentially, where n is not equal to 0. It can't be, otherwise it would be undefined. We'd be dividing by 0. And we know p is greater than 3, which means this must be greater than 0. Okay? Which equation correctly expresses n in terms of p? Well, every answer solves for n, so essentially we just need to solve for n. How do we do that? Well, first I'm going to take the 3 over to the other side by subtracting 3 from both sides. Okay. Now I'm going to take the reciprocal of both sides. So 1 over p minus 3 equals n divided by 2. And now I'm going to multiply both sides by 2. And I get 2 over p minus 3 equals n. What's the correct answer? C. N equals 2 over p minus 3. Okay, number 12. Looks like I've got a system of two equations, but I have a constant p in here. So this is probably going to be a solve for the constant type problem. In the given system of equations, p is a constant. The system has no solution. So always looking out for always true or no solution. This is no solution. What is the value of p? Okay, so if there's no solution, I know my constants are different. Therefore, I want the terms 3x and px to be the same. My y values would then be the exact same except for the difference in constant, which means there's no x value I could apply that would make these equations the same y value. And that would be no solution. Essentially, it would be a line or two different parallel lines with different y intercepts right here, the constant values, which, as we know, two different parallel lines, they never intersect. Therefore, there is no solution to the system of the two linear equations. So, all right, what does that mean? That means my p must be the same coefficient as the top equation, 3. Simply p equals 3. Okay? If you need to see it written out, that means y equals 3x plus 5. And the other equation is y equals, substituting p equals 3 in, 3 for p, x plus 8. These equations will never, ever be the same. If I set them equal to each other, 3x plus 8 equals 3x plus 5. Subtract 3x from both sides. 8 equals 5 is never true. Okay? The correct answer for 12 is D. P would equal 3.